Hello guys, today we are going to perform our next experiment, that is IR sensor circuit. For that firstly we need all the components of the circuit to be here. For that we are using add part tool. Our first component and the most important component of this circuit is a operational amplifier, that is LM358. The code for LM358 over here is LMV358mm. Yeah, here you can see it is here. It will be placed in two parts. With first click, first part is placed. With second click, second part will be placed. But before placing the second part, you must rotate the component. So place it like this. Here you can see 8 pins are here. Now another thing we need is a photodiode or a IR LED. For IR LED, we are using SFH482. So IR LED, you can see, click over here. So place it like here, and second one is here. Because it is a dual sensor circuit, it contains two IR sensors, so we are placing it two times. Next we need a photodiode, that is BPX65. So photodiode, click over here and place it like here, and another one is here. Next we need some resistors. Again we are using the same resistor RUS. Select anyone from this category. One for the IR LED, one for the photodiode, two for these two outputs to connect LEDs, one for this photodiode and one for this IR LED. So in total we need 6 resistance. Another thing we need is a potentiometer. Potentiometer, you can use the RCL potentiometer. Rotate it and place it in front of the inverting pin, and here in front of the inverting pin. So next component we need is a LED 3mm. So here is the LED. So we need two LEDs over here. First for this output, second for this output. Last thing we need is a connector, that is a 2-pin connector MTA02-100. This is the code for the connector. It's a AMP connector. Okay, and place it here. So we have placed almost all the components. Next thing we are going to do is connect all these components via net tool, like we have done in other circuits. Click on net and connect all together, this to this, and then forward it to this and this. All the upper portion is connected, same as ground, here, and from here it should be connected to LEDs. Connect both the LEDs together. Okay, fourth pin is ground, so connected to the ground. Eighth pin is positive, so connected to here. And this is for the output that to be obtained from pin number 1 and pin number 7. Connect this resistance to the LED, it will tell the indication about the output, and from here we can take external output. So connect the external output to this connector. Next thing, this resistance to the IR LED, this to the this, and connect this terminal to inverting pin. This is ground, this is positive, same for the other one, ground, positive, and inverting pin. So at last we are left with the non-inverting pins that to be connected with the photodiode. So connected over here, and it should be connected with here. Same for this side, connected with the photodiode. We have done all the connections for the IR circuit. After connections, now we will check the circuit for the errors. For that we will click on ERC. So here you can see there is no error, but there are lots of warnings. So we will see these 6 are the warnings for the resistance, because we have not given any value to the resistance yet. So we will give them value. So J1 has no value, it will be ignored because it does not need any value. Either LED does not need any value. So power pin is connected to VCC and this connected to ground. This is okay. All we need to do is to give the values to the resistance. So let's start from here. Value 330 ohm. Here it is 10K. Again 330 ohm. Same for this. And this is 10K. And the last one is again 330 ohm. After giving the values, again we can check for the ERC, where you can see potentiometers also need some value. So we will give values to the potentiometer also. It's also 10K. 10K. So if we check again, here only left with LED values, connector values, and 2 warnings for power. That's all okay. So we will move to next step. So next step is to save this circuit. Save with the name IR sensor. IR sensor, we have saved this. Now switch to board. Get from schematic, yes. So as usual, here you can see all the components and a black screen over here. So you need to place one by one all the components. Firstly, we start with the IC. This is the IC. I'm placing it here. Next component that is connected is resistance. This here, photodiode. Make sure to connect these components accordingly their side, which side they are connected in circuit. So it will solve your circuit at a certain level. Like here, this diode is connected to this pin, this diode is connected to this pin, so we have placed this on this side. Same for the IR. This is connected to this, so place it over here. another IR is connected to this. So it's output connector. Place it over here. I think this resistance should be connected to this, and it's also connected to here. This is the output resistance that is connected to LED. Place this LED accordingly. Next, this resistance that are connected over here. Now simplify this circuit as much you can. It is of this side and this is for this side. You should place it over here. Rotate the components for better connections or simplification. So almost we have connected all the components. Align them for a better look. So after aligning, you can perform the next steps. Our next step is to reduce the size of this PCB. So here, so we are done with this size, and next step is our polygon tool. Make a boundary with it. Signal name empty. Okay, and the last step is auto router. Click, continue, start. So here you can see some parts are 100% optimized and some are 71%. So here you will use only 100% optimized path, because in 71.4% optimization all the connections are not made. So if you want to use all the connections, then you will use only 100% optimization. You can select any path from 100% optimization. So it's look good to me, so I'm going with this. End job and bottom layer. So here is the connections, and it's all about your IR sensor part. Thanks.